Okay, good afternoon. Welcome to
FamilyMath869.
FamilyMath869. So I don't want you to say anything about this one yet because we've been studying parametric equations in calculus, and this is going to be a project about parametric equations. But you have not seen parametric equations before,
No.
have you?
Yep.
Or even really trig functions, which is this particular one is. So I would like you to tell me what do you see here?
Well, I see this. There's this sort of kind of loop line. It's kind of going around the origin. Sometimes it crosses the origin, and then there's like sort of a line going along that. One point's on the line, and then another point is slightly off, and they're connected by a line.
Sorry, our dog bumped the camera there. Okay, yeah. And can you tell me anything about the line?
So it seems like it varies in length. So as it comes down here, it gets really long, and then it gets really short, and then it gets even longer, and then it comes back, gets really short.
Okay.
Seems to get longer and then shorter again.
Nice. Can you tell me something about this line?
This line, I believe this line is matching the slope of our curve.
Okay.
At where the point that's in contact with the line is.
All right. And so what does that mean about the line if it matches the slope of the curve?
So the line's going to be changing. Like, it's going to... I'm not sure how to explain its length changing, but the slope of the line is going to be changing constantly.
Okay, the slope of the line changes constantly. How does that relate to the curve?
This line, I guess, represents the derivative of the curve at this black point here.
It represents the derivative. So tell me what you mean by that.
It represents, I guess, how the function is changing at that point.
Okay, so this line is tangent to the curve.
Yes.
Okay, so that means it has the same slope. I've set this up so that the length of this line it varies by the speed. So when it's getting longer, it moves faster, and when it's getting shorter, the length of the line is shorter.
Okay.
I've actually scaled it just to fit it on screen. The length of the line is equal to 1/5 of the velocity, but it's just proportional to the velocity.
Interesting.
Cool.
So as it moves along the curve, sometimes it's moving faster, sometimes it's moving slower.
All right.
And now I'm going to add in, I have the acceleration set up as well, but I'm not displaying the acceleration yet. So we've talked about acceleration a little bit in calculus as just being the second derivative. But what does acceleration mean to you? We've never talked about acceleration before. So what do you think acceleration means?
Well, it's like how something gets faster and faster.
Okay.
At what rate it does that.
That's a good description. What does it mean to you?
It means, I guess, it means how the velocity changes.
Okay. How the velocity is changing. Acceleration happens in a direction. So if I were to stop this at a particular point, I don't know, let's stop it here. What do you think is happening to the acceleration, or what direction do you think this particle on the curve is accelerating?
Well, it's accelerating like down and to the right along this straight part.
Okay, what do you think?
Well, it's getting, this point just going along here, it's getting faster as it goes along. So I think that's right.
So put it with, like, say, this pencil on the screen. Like, where do you think the acceleration is going, or what direction?
So, like, kind of down this way.
Okay, and where do you think?
Sort of like it's going down. And
Okay, let me just put it in. So there, it's accelerating over that way. So I'll let it go to a different point. How about here? So where do you think the acceleration? What direction do you think this thing's being pulled in by the acceleration now?
So before it was going like, I think it's being pulled kind of like this way. It's just right rounding the curve. So around here.
Okay.
I would even say that it's maybe a bit more vertical. I'd say it's like that.
Okay.
Maybe even perfectly vertical if
All right.
we got lucky. Oh.
So it was going really fast this way. Now it's slowing down and going around a corner. So it's actually the acceleration is being heavily pulled that way.
Interesting.
So let's just let this play. And so now you see the acceleration, which way the acceleration is going. And the acceleration, when you're learning about it, is pretty non-intuitive.
Yeah.
So you can see the velocity, and the acceleration is also divided by 5 just to fit it on the screen. But you can see this is being pulled pretty hard sometimes.
Yeah.
Right at the
Just
corners.
To slow it down and also get it to reverse directions. You really got to pull hard. And that's what the acceleration is doing. That's actually pretty neat to see.
Yeah.
All right. So this particular curve that we're looking at here is sine of 4t, 3 cosine of 3t. Is that on screen?
Yes.
Okay. So what I'm going to have you guys do now off screen, I'll have you pick an equation first, and then we'll do another one where you pick one. Okay.
All right.
All right. So we'll do that off screen.